Welcome to day 5 of this 3D asset tutorial series. If you're just starting to join in with this series, you can always refer back to my website www.andrewbooth3d.com. Halfway down the page you'll see the section of my past videos. You can also get to the videos on a tab here. I'll be creating one in the near future. It'll be named tutorials, and all my tutorial videos will be linked there, so bear that in mind. Okay, last time we discussed about UV mapping and the importance of a good UV map, and about distortion and controlling that distortion and having proper correct UV. Now the next bit is just as important. We are now be discussing about layout. Layout is very important because if you have a really good layout, you can increase the UV shells, and by increasing those shells you can actually increase the resolution of the model. Now, resolution of the asset is highly important. It's very hard to do, purely because of the scene. As a scene as a whole, you have to have the correct resolution throughout uniformly. With my artwork, I don't necessarily do that because it's not about the actual scene, but I showcase my work individually. As you looked on my website, I have individual actual assets, and because they're individual, I had to have them, high res, more high res in this than on this scene is needed because I'm showcasing them. So it depends on what you actually require the actual asset to be. If it's just a showcase kind of 3D asset, just showing your skill off, and it's basically, just for show, just for art purposes, then resolution isn't the key. It's basically all about what you're working towards. If you're working in the scene, then do keep correct resolution, because that is important. If you think about it realistically, if you have a tire of a fan, and then the main body of the fan, but the wheel is more high resolution than the fan, then it won't look right. So you have to justify that the size of the resolution accordingly. There are many techniques to do that. I will show you that in the next video, because that is in itself an important step. For this step, I'll be discussing to you layout and why it's important, and then start to work on to the actual generation of the initial maps, like ambient occlusion and all that kind of necessary steps, and even work into the high to low poly method. That is highly recommended. You can generate normal maps from there, but I'll talk to you about normal maps in the near future. So for this tutorial, we'll be just talking about the layout of this salt dispenser. As you can see, we have all these islands, these shells. They're all different size and all at different resolution, as you can tell by the actual 3D model. Now, first of all, what I tend to do to sort out this mess, because it is a right mess, you have a big island here and a small one here, and it's not a correct layout, I just simply select all of them, select all the UV shells, right click, polygons, and layout. This menu brings out many different options. It depends on what you are after as an asset. For example, you have no prescale, which means it will not scale any of these shells. You have object, so all the UV shells is scaled to the object opposed to anything else. You have world. In other words, this means if you have an environment, like a scene, and you press that, it will scale the UVs to the object in comparison to the scene. So if you're working on a big scene, that is ideal. And you have scale mode, you have uniform, none. Obviously you have no scale mode, so it'll keep it to the same size. All this, what you have already on the screen. Uniform, so they're all the same size. And then stretch to region. Basically, it will fit it to the region of this 1x1 square. And you also have rotation. Basically, if you're wanting a rotation, you can always have a 90-degree rotation and then a 3, which means it can go to any rotation necessary. The reason being these are here is basically again to what you specifically require. A 90-degree angle, because certain shells fit better on a 90-degree angle, or in certain angles where others isn't so apparent. On obviously 3, so the computer will compute a layout with an angle system. Each shell will be angled a certain way, so it will scale and get the best choice, computed choice for a layout. You also have spacing preset. This is to do with the size of the actual textures you'll be working on. As you can see, it goes from 32 all the way to 2048. I work on 2048 as the highest map because that's the highest permitted texture size output in Substance Designer and stuff like that. I mean, we can go higher. It will allow to go higher in Substance Designer, but it's limited to that amount. It won't display any higher, so I would not, it will not display any higher. It does allow for 4K maps, so double that again, which would be 40, 80, so 4096. If you're wondering what I was working out, how I worked that out, the size of the resolution is always a power of 2. So 512, 1024, 2048, and 4096. So I go through this list depending on what I require. This top one, it's not so needed, depending on how many models you got. You got per object, overlapping, and single or multiple non-lapping. Basically, this means if you select more than one object to lay out, you can select all the objects and click that, so then it will lay out each model so that it will overlay and it'll be correct layout for all models. Whereas single or multiple objects, none overlapping, basically means it will unwrap not unwrap, the layout the actual UVs dependent on the actual single sheet of the UVs. For example, if I click this and I had 2 or 3 of these soap dispensers, it will lay them all out the same in this region, or similar to in the same region, where if I click this, they'll all be on the same map. So this is good for laying out a good light map, because light maps deal with a second UV set, and I'll show you how to create that second UV map, second UV set next time, because it is highly important. Certain objects don't need it, but for more advanced objects, it's always handy to have a second set of UVs. I always keep mine to object, so it's uniformly. And we just go through and click apply. As you can see, it laid out my UVs pretty well. If you turn on the distortion, as you can see, it's literally sorted out all the distortion problems accordingly. It's all even colour, and it's pretty well done. But although this is a good layout, this is good for initial kind of layout. You just work back into it, because although it's laid out, it's all about trying to find new ways to fit all these in the same square more efficiently, so that not only can you got a good workflow going for when you're using substance design, or when you're texturing, you know, organising your UVs to your specific needs, but you also work back into it so you can increase the texture resolution per unit, basically. So you increase it and get the most out of your texture square, basically. And from this point on, it's all about a puzzle, you know, fitting them all back into the same square. That's all it's all about, fitting it all back in the same square, trying to find a new layout that would allow, you know, a better layout, so that they will all fit and you can get a more increased resolution. In certain cases you can't, but it's all about, like I say, a puzzle. That's all it is. These pieces are pieces of a puzzle, and you fit them in that one square. Now, one thing I will alarm: always keep a gap between the edges. This is to prevent texture bleeding, because sometimes certain texturing software and game engine bleeds in their textures, so it's always good to allow for that. Like I say, it's all about just working back into it, getting the correct layout that works. That's all it comes down to, really. And like I say, it's again like unwrapping the UVs. It's a tedious job, but once it's done, it's done. Now that's slightly better, but as you can see, there's a lot of gap here and here, that's because there's so much. That's because the texture is, although it's unwrapped and laid out, there's not enough UV shell geometry, to fill those squares. So now I'll be looking into improving the layout. Now people do it differently. Again, there's all different ways of doing stuff. With this, it's all about what you want to be seen and what you don't want to be seen. And although having a uniform resolution across the model is always good to have, sometimes it's better to reduce it in certain areas that you know is not going to be used, customizing and compensating for it. Justification, like for example here, although it's the biggest square, and to be equal to these bits here, it needs to be big. But the problem is, it's not going to be seen that much because it's going to be flat on the table. Anytime it's going to be seen if it's get knocked down or be moved. So a lot of this is texture space wasted because it's in a sense not being seen. And so when you think in that concept, you can get a way of reducing the resolution slightly. By reducing it slightly, you'll be able to fit UV shells more better in comparison to when it was bigger. If you can fit it in more better, you can have a better layout. And this is what it's all about. Find that perfect layout. Find a way to fit them all into place and look good. Now, as you can see, this here is correct. The texture space is correct for this spot here. But the trouble is, it's small. Because it's small, when you come to normal mapping and stuff like that, it's going to be pixelated because in a sense you're putting information in here, and if you require a lot of information, it's going to be a little bit more pixelated. So for me, these bits here I increase the size like so. I know it throws out in comparison to the rest, but the problem is it's going to be like on top there. And if it's going to have details on there, like on top there, I'm going to have a P. If I'm going to have a P there, or S for salt, it's going to be pixelated if I don't. So I've got to increase it so that it's not going to be pixelated. Now, if I'm going to have a P, I could have that as like a decal. Now, if you wonder what a decal is, I would explain that in the near future, so don't worry. Also, when you come to laying out your UVs, sometimes it's good to cut some of the UVs up again. Recut them into a smaller chunk. Like here, it's thin, but it's too long. Because it's thin but long, it's hard to fit it in. So cut it up and replace them in. As you can see, it allowed for a better layout, and because of that, I can then go select them all, move it to the center, and then scale all of the UV shells ever so slightly. Now, what I normally do, I normally cut a second line there. But with a model like this that's all cylindrical, it doesn't matter too much. Only do it when you know it's necessary. Now, this top bit, as you can see, it looks too big for these squares. So what I would do, although it's reasonably the same size to the rest of the model, in terms of these bits here, which is smaller resolution due to the shape of the actual model, I would actually increase it so it's reasonably more resolution, get more detail in there. And this is what you do. You just work it into it until you find a good layout that works. It takes time, a lot of time. But once you've got a good layout, it would work really well. In some cases, it's about editing certain pieces. Again, like this piece here. I noticed there's a little bit stretching that needs to be sorted out. These are not quite squares, so just decrease it, increase it like so. That's perfect. And from this point on, it's about what you're after, basically. Sort into categories. This is part of wood, so it'll go here and here. This is going to be gold, so all the gold bits in the same area, like so. Now, you don't have to always fit them in, like so. Actually, I don't know, decrease that. That's better. It was too squashed. Now that is a really good layout, and again, that's key. This is what it's all about, finding that good layout. Fitting it in puzzles, basically. Now I'm tempted, I'm now going to leave it like there, like that, because I don't think it could be improved anymore. Although I've got little texture space here and here, the rest fit in just fine. In fact, I'm going to lower it slightly because it's too high there, like so, to allow that little gap there, a little there. You don't have to use all the texture space, but the idea is to get as much space filled as possible, and then save it so you don't lose it. Now, the reason being it's good to have a good UV layout is because of resolution. Now, the next bit I'm going to talk about is ambient occlusion. Ambient occlusion is the light information between shadow and light. it's like creating like a texture map that will tell the computer this bit is more lighter than a bit over here where it's in the shadow. It's good when you're in a like a more enclosed area. So if you have like a spotlight underneath here, you know this bit's going to be always dark. So is this bit always going to be darker, but this will be more lighter. That determines that map. That map actually tells the machine what part is going to be more lighter and what part will be shadow. And it's always good to render these, generate these maps in Maya. Now, don't get me wrong, Substance Designer has that ability as well, but it's not so accurate. So let's start it off by going to Windows, When Editor, and Hypershader. When it loads up, I will explain to you what this does. As you can see, it brings this window up. This is the Hypershade. The Hypershade is basically containing the library of every single shader that Maya has. Now, as you saw, the shader is basically is the Maya computing the actual material, which these are materials, shading the materials using information like the diffuse and all the actual information. You're telling it, hey, this is rubber, this is this material, this is ocean, this is this. Each shader has its own settings, its own parsers, which is what they call it, or used to call it. Like mental ray. Mental ray is a shader that goes through a series of parsers to create realistic lighting and information based off its parsers and of its textures. That's why mental ray looks more realistic, but equally it takes a lot more memory of the computer and time of Maya to compute that information. Now, how I generate these ambient occlusion maps is by using a shader. I use the surface shader, and then in the out color I select, if I can find it, MIP Amp Occlusion. Basically what you're doing, you tell the machine that the material that you're assigning object is going to be a surface shader, which means it's going to be not rendered, it's actually going to be whatever's placed, it's going to be placed in the surface shader. It's going to be placed on the surface. And the mid-ambient occlusion records the light information and then computes it onto the surface shader and then renders out as a texture map. So what you just do, you right click, assign, you can't see it, I cut it up, I do apologise for that. Assign the assistant materials and see surface shader. I do, as you see, Maya do sometimes play up. At the moment you don't see anything change because it's got the default checker assigned to it. So you click this button here to take it off. As you see, it's changed to black. Now to render out you go to this menu here, drop down to rendering, lighting and shading. Then you select, if I can find it, I do apologise, I haven't seen the new menus from this from May 2012 and 2016. So I just done a basic render, a batch render, and that's what it comes out with. All the light information. Obviously that's not what you want. Obviously that's not what I want, so I've just clicked it to make sure it's the right one. You click this little square button and it brings onto the actual menu. Here records all the information to your specified needs. You always have to have it selected so you can't get confused to the entire scene, which will take some time, trust me. And then bake to a texture map. Bake and optimization. Because we're just doing a single object, it's best to click single and then perspective, and then use bake set override, which is always handy. And then occlusion rays tells it how many rays there is in the actual occlusion. You name it a certain object. I just call it salt, and then set the resolution and how many samples. This is important. Number of samples is how many samples per pixel, I do believe it is, or something like that. That you do need to research into. Now I always have it at 50. This means it's going to be high quality. And final gathering at 10,000. It's the final gathering that's key. Now with this, it records light information from other objects as well, which means this object will cast a shadow this area, as you saw when I rendered it out. So what you need to do is to delete, is to hide the object, and then zero out the soap dispenser, as you can see here. This soap isn't zeroed out. To zero out, just go 0 at the top, 0 and 0, and it's sealed out to the actual center. And because it's dealing with light rays, it needs light rays. It's all about bouncing off light, and for light to catch at the bottoms here, where realistically it would be if it's placed on a table, it needs a surface to bounce light from. So always do like a plane map, you know, a plane kind of you can find it. There it is. I don't know what happened there, but it's always handy to have a plain kind of it's handy to have a plain floor attached to the bottom. It's to allow light to bounce off of it onto the object. Don't have it completely on the floor because attached, because if you do, the bottom would be completely black, and that's not ideal. So always allow a little space, like so. Just click the item, bring up the batch bake menu, which for some reason has closed. May I do that to save memory, I do believe. Just reclicking it and convert. This will take some time, so I'm now going to end the video here. When we come back, I will show you this converted map. So please do follow on, and tomorrow's session we'll be discussing normal maps, you know, a second UV set and more interesting stuff like that. So I bid you a good night and see you tomorrow.